Solving quadratics by completing the square. In this video, we're going to do both. We're going to do solving quadratics, and then we're going to actually write the equation of an equation in vertex form. All right. So here's our two forms that we've seen so far. We've had the standard form, which is ax squared plus bx plus c, and then we have our new form here, which for our quadratics, this is the vertex form. All right. What's nice about this form here, the vertex form, it actually gives me the vertex of my parabola. So the h and the k are my vertex. So if you have your parabola or your graph, wherever your parabola is, wherever your vertex is, this is my h and k in my formula. All right, so for example, if we have an equation, f of x equals x minus 5 squared plus 3, my vertex here would be 5, comma 3. The h and the k of the formula. Something to consider as well, if you have another equation, g of x equals, let's say, x plus 7 squared minus 4, your vertex here is going to be negative 7, negative 4. Okay? Why? My formula has x minus h. So how do I rewrite x plus 7 with a minus sign? That should be written as what? X plus sign can be written as x minus negative 7 squared minus 4. Alright, so your two negatives here. So what's my h? So my h is actually negative 7. Okay, that negative sign is part of the formula. Whatever your last term is, if it's positive 3, then your vertex form of that is your positive 3. If it's negative 4, then it's negative 4. It's just the one inside that you have to be careful for. Okay, so this is my vertex form, giving me my h and k of my vertex. Let's take a look at an example. We're going to first start off by solving these. But before we solve these, I want you to consider these, right? Factor these out. What do you get when you factor these? What are my two quantities when I factor x squared plus 4x plus 4? Split up my x's. What else? Right, this would be x plus 2 and x plus 2. So this is a perfect square. So this is the same thing as saying x plus 2 squared. What about my bottom one here? X squared plus 6x plus 9. This will factor into what? X plus 3, which is equal to x plus 3 squared. So I'm looking to create this. This is exactly what I want to create. I want to create a perfect square. Now, all my equations will not allow me to do this, but we can alter the equation a little bit and actually have this happen. Let's take a look at our first example. So we have x squared minus 14x minus 48 equals 0. Now again, completing the square is just another alternative to another means of finding your roots of your function. So you could just factor, set them equal to 0. You can use the quadratic formula, or you can use this form, which is completing the square. First, let's get everything over on one side that does not have an x. So let's bring this one over. So we're going to have x squared minus 14x equals 48. Just adding 48 to both sides. All right, so let's get our x's on one side. I'm going to rewrite this and I'm going to leave myself a little space. So x minus 14x, I need some term here equals 48. I want to create this c term here. So if I think about my equation, ax squared plus bx plus c, I want to create this c here. I want to put a plus c here. So I need to figure out what that c is going to be. But I want that c to work out so that I can factor this into a perfect square. So how do I find this c term here? So we're going to say the c equals, we're going to take my b term, whatever the b is, we're going to take half of it and then square it. And that's going to give me my c term. So if we use this one, so we're going to say b is negative 14 divided by 2 squared, which is going to be negative 7 squared, which is 49. So the term that I'm going to put here that's going to make this work perfectly for me is going to be x squared minus 14x plus 49 equals 48. So this 49 is going to make this factorable into a perfect square. But I can't just add 48 or 49 to one side. So if I do that, it's going to unbalance my equation. So if I add 49 to the left, what do you think I should do to the right? Add 49 as well. Okay, so this is very important. Add your 49 here. So now, if I factor this, x squared minus 14x plus 49, I could factor this into x minus 7 times x minus 7 equals, what's 48 plus 49? 97, perfect. Okay, I'm going to rewrite these two terms as x minus 7 squared equals 97. So let's recall some facts. If you have something that says b squared equals 16, how do you solve for b?
Use square root both sides.
Take the square root of both sides and you get b equals plus or minus 4. Well, same thing here, except now you have a quantity. X minus 7 squared equals 97. So I'm trying to get the x by itself. So let's take the square root of one side. What I do to one side, do to the other. So now my square and my square root will simplify, leaving me with x minus 7 equals the square root of 97, which is just going to be plus or minus square root of 97. Can't factor, can't take the square root of 97 as prime, leave it just the way it is. We're solving for x, so let's just add 7 to both sides. So here we have x equals 7 plus or minus square root of 97. Now if you look at that answer, it almost looks very similar to what the quadratic formula would also look like. X squared minus 16x plus 48 are our next example. Alright, so let's start off by solving this and or just getting the x's on one side. Let's bring this positive 48 to the other side. So we got x squared minus 16x equals negative 48. Now I left a little space for myself here already. Alright, in anticipation I have to create another term here that's going to make this factorable into a perfect square. So I want that other term. So again, I'm going to take my b. So I'm going to take negative 16 here on the side, divided by 2, and square it. So this is going to give me my negative 8 squared, which is equal to 64. So I'm going to add 64 here so I can factor this into a perfect square. I added 64 to the left. What I do to the left, I must do to the right. X squared minus 16x plus 64. This should factor into x minus 8 times the quantity x minus 8 equals negative 48 plus 64. I get an answer of 16. Rewrite this, x minus 8 squared equals 16. I don't want my square. How do I get rid of my square? Take the square root of both sides. So I got x minus 8 equals plus or minus 4. Do not forget your plus or minus 4. The square root of a number is the positive and the negative of it. Alright. Add my 8 over to both sides. Plus 8. Again, I'm going to put that 8 or whatever I add over to the other side. I'm going to put it in front of my plus or minus. So x equals 8 plus or minus 4. That's just a preference. So here x equals 8 plus 4, which is 12. Or x equals 8 minus 4, which is 4. 3x squared plus 5x minus 12 equals negative 4. Alright, so same first step. So here's a little bit different. We have a leading coefficient of greater than 1. Alright, and this problem is also going to give us some fractions, which we all love. Let's get this negative 12 to the other side first. So we got 3x squared plus 5x equals, I'm going to leave myself a little space here, negative 4 plus 12, I get an answer of 8. If you have a leading coefficient and you're solving, okay, when we're writing the equations, it's a little different. When we're solving, it's a little different. Okay, so if you're solving for this for x, just get rid of the leading coefficient. Let that be your first step. So, or your next step, divide everything through by 3. So here you're going to get x squared plus 5 over 3 x equals 8 over 3, creating some fractions. I still want this last term here. I need to get a term here that's going to make this a perfect square. So I'm going to take my middle, my b, so 5/3. I'm going to divide it by 2, and then I'm going to square it. What is 5/3 divided by 2? Yeah, perfect. So this would be 5/6 squared, which equals 25 over 36. Now I definitely suggest doing this step here because this 5/6 is going to come into play very soon. Alright, so I'm going to add 25 over 36. Since I added it to the left, I'm going to add it to the right here, 25 over 36. What do I get when I factor this? x plus, what are factors of 25 over 36? Well, they're right here. Your 5, 6. Those are your factors. So x plus 5, 6 times x plus 5, 6, or x plus 5, 6 squared equals. Here I'm going to reduce this. I'm going to multiply this common denominator. I'm going to multiply this by 12. So I get 96 plus 25 over 36. So I get 121 over 36. Those numbers should be looking pretty nice to you right now. Take the square root of both sides. X plus 5 over 6 equals plus or minus 11 over 6. Taking the square root of 121 and square root of 36. Subtract 5, 6 from both sides. Minus 5, 6. So I'm going to get x equals negative 5, 6 plus or minus 11 over 6. So x equals negative 5 plus 6. I'm sorry, negative 5 plus 11 is 6. 6 over 6 is 1. Or negative 5 minus 11, which is negative 16, over 6, which is negative 8 over 3. So your two solutions here are 1 or negative 8/3. 2x squared minus x equals 5. Alright, so my x's are on one side by itself, so that part's set up. I want to get rid of this fraction, so I'm going to clear my fraction here. So I'm going to divide by 2, divide by 2, divide by 2. So here I have x squared equals, x squared minus 1/2 x equals 5 over 2. I need my third term here to make this a perfect square. I'm going to take my middle term, divide it by 2, and then square it. So I get here what? Negative 1/2 divided by 2 is negative 1/4 squared 1 over 16. So then this is going to become plus 1 over 16. I added 1 over 16 to one side. What I do to one side, do it to the other side. Add 1 over 16 to the other side. Factor this. Again, this is going to help you with your factoring. That middle term here. Okay, this is going to be my negative 1/4. So x minus 1/4, I'm going to have two of those, squared, equals, if I do this, 5/2 plus 16, common denominator 16, multiply them both by 8, I should get 41 over 16. Want to get rid of my square? Take the square root. Take the square root. So I got x minus 1/4 equals plus or minus square root of 41 over 16. Can I take the square root of 41? So it stays at square root of 41. Can I take the square root of 16? 4. So square root of 41 over 4. Add 1/4 to both sides. Plus 1/4. So I have x equals 1/4 plus or minus radical 41 over 4. Or since they both share a common denominator, I could rewrite this as x equals 1 plus or minus square root of 41, and both of them over one denominator. Either answer is correct.